lesser than the sample density. A sample density is more than the gradient density. A gradient is going to have lesser density than any of the sample density. So, a centrifugation is going to be taken place for the low speed, because a density is less than the sample. There will be a low speed centrifugation occurs for the short time, which lead to separation of a component as a discrete zones. Discrete zones means, as it's going to have a low density, a gradient is going to be at the top, a sample is going to be at the bottom. Of its similar density gradient, then the sample is going to be at the bottom. Likewise, another density gradient is at bottom, another sample is going to be at the bottom of the gradient. Based on its density of a sample, it's going to be separated, but it was separated as discrete zones below its gradient. So the major rotors can be used as swinging bucket rotors, because it's going to be have a decreased speed of RPM and decreased wall effect. Decreased wall effect is very needed, because here there is only a small differences in the density of discrete zones is going to be formed of, which can be disturbed if there is a wall effect is possible, may affect the sample separation. So the major advantage in this is going to be particles differ in size can also be separated, but density based on density is not possible. So a separation of these components, cellular components, can also be possible in this method. As it was going to be separated based on size, a cellular component separation can also be possible. Even RNA DNA hybrid and ribosomal subunits can also be possible to be separated. Proteins which differ in small molecular weight can also be separated, because it's a fragile process. But a cellular components of like mitochondria, lysosome and peroxisome does not be separated by this method.